So this time the rate law of the general equation is this one. Explain the meaning of K. Okay, so if this is the rate law, we are to explain the meaning of K. So K is the rate constant. Okay. That is the rate constant or the proportionality constant in rate law. And then letter B, explain the meaning of M and N. Okay, so here M M here is the reaction order with respect to reactant A, while N is the reaction order with respect to reactant B. Now we have here, does M is equal to A and N is equal to B? Explain. No. The order of reactant does not necessarily equal to its stoichiometric coefficient, and we know that we cannot determine the value of A and B, oh, the value of M and N by just looking at the equation. But we can identify it from an experiment. Okay. And then, if the reaction is first order in A and second order in B, okay, so if reaction is first order, so the rate is equal to K, and then A is first order, then B is second order, so that is the square. And time is measured in minutes. Okay. What are the units of K? What is the unit of K? Alright, so the answer is liter square, mole square, per, liter square per mole square second. Okay, let's solve that one. Let's see how did we get that one? Okay, so rate, okay, let's write. We have rate is equal to K times A, and it's B square since it's second order. We are to find the value of K. Now to get the unit of K, so we have to rearrange the equation by dividing both sides by A and B square. Concentration A times concentration B square. So we will have K is equal to rate over A concentration of B square. Okay. Anyways, we know this equation. We have this in our lecture. That to find K, we have this equation. Alright, so let's substitute the unit. What is the unit of rate? The unit of rate is mole per liter times the time. Okay, in this case, it's minute because it was said here, minute. Okay, over the rate, the unit of A, since its concentration, we have mole per liter times mole per liter for B, and that is square. Okay, so this would be equal to, okay, mole per liter, cancel, we can cancel that one, and then we are left with minute. Okay, that is, we are left with minute. Okay, raised to the negative 1 because it's denominator times, over, okay, let's write it over first, over mole square. This is square per liter square. Note this is equal to that. Note that minute raised to the negative 1, that is 1 per minute. Any number raised to the negative 1 becomes a fraction. Okay. That is 1 over the number. Okay, so we have to multiply this one, reciprocal. So this is liter square, and then mole square. So we have here the unit of K, which is equal to liter square per minute mole square. Okay. Or we can say the mole first and then the minute is okay. So we have K is the unit is liter square per mole square. Let's have the mole first and then minute the second. Okay. So this is the unit of K. So how did we do that? We just plug in or substitute each unit. So the unit of rate, which is mole per liter minute, over the units of the concentration. And then we have here, because mole per liter and then mole per liter, so we can cancel that one, and then we are left with minute. Notice here that it is negative 1, raised to the negative 1, because this is equal to mole per liter minute. Okay. So minute is a denominator, and then when we cancel this one, so when we put it on top, we have to make it negative. We have to raise it to the power of negative. Okay, so that's it. All right, so here's our answer. Okay. So if your answer is this one, then you got it right.